Hey, what's up, guys? John here. And so today, let's take a look at this week's weekly contest. One of the problem. So number 1,547. It's hard to believe it's over 1,500 problems already. Okay, minimum cost to cut a stick. It's a hard problem. It's a very classic problem. I don't know if it's a hard or like medium hard, but anyway. So you're given like a wooden stick of length n units. The stick is labeled from 0 to n here. For example, a stick of length 6 is labeled as follows. And then you're given like an array of cuts. So basically cuts I means to make a cut at the position at this position. And each cut will have a cost. So the cost will be the length of the stick you're going to cut. And so it asks you to, with this cuts here, you need to find an optimal solution. An optimal solution that the total cost is minimum. For example, you're given like 1, 3, 4, 5 here. Okay, you have different ways of cutting the woods here, cutting the stick here. You can so the first time when you cut a place, right, you get like 7 as a cost. And second time, if you cut 3 here, as you can see here, so you cut 3 here, and then the cost will be 1 to 7 will be 6, right? And then you cut 4 here, will be 4 cost, and 5 will be 3. The total will be like 20. Okay, but if you rearrange the cutting sequence to 3, 5, 1, 4, the total cost will be 16. So I mean, so this is like a very typical like top-down DP problem. So basically, what's the D? Oops. Hmm. So basically, the DP, and we're gonna define like DPIJ here, right? So what's the DPIJ means? It means uh, to cut from I and J. That's the starting and the point. From I to J. What's the minimum? What's the minimum cost to cut DPI and J? And so for DPI and J, what do we do, right? So we it's simple, right? We just get the all the possible cuts between I and J, and gonna be the minimum, right? Okay, sorry. Gonna be DP I to K plus dp k to j, n plus what? N plus j minus I. Okay, so that's the state transition function here. Basically, to cut to I and j. So assuming we find a place to cut k here. I mean, so for this k here, we're gonna after cutting this like stick into two substicks, we'll have dp I and k, and then dp k and j. And then, so this J and I means the current cost, the cost to cut the current stick. Okay. And the K here will be all the possible cuts between I and J. Yeah, that's pretty much it is. Basically, for each of DPI here, we're gonna loop through the cuts here. We're gonna loop through all the cuts. So if there's a cut between I and J, then we just call this DP here. And for all the K's here, we do a minimum. Okay, we'll choose the minimum for all the possible cuts. Mhm. Yeah, so basically, so every time when you guys see like this kind of, you're given like a different cuts and they ask you to find like a minimum totals. I think the I think the natural way of thinking is like to always try all the possible cuts. Okay, and between and among all those possible cuts, we'll get the minimum from them. And since as you can see here, so since for this problem, we're cutting the stick from the beginning, which means it's a It's a great candidate of using the top-down DP solution here. And yeah, and one more thing is that so once we have I and J here, we don't need to we don't need to care about the remaining cuts here because let's say if we after cutting the one here, right, and for 1 and 3 or 0 and 1 for these two sub sticks here, we will not be so we will not do a cut one more time because we will only uh we only look for the cut between the 0 and 1, not 1 here. That's why we can simply ignore the cuts here. We can simply just use the DPI and J to uniquely identify the state here. Mm. Okay, cool. So with that being said, let's try to code these things up. And so for top-down DP, right? And start and end. Okay, so memorizations, okay, and return DP start is 0, end is n. Okay, so if start and end in the memorization, right, we simply return the memorization. Okay. Okay, that's that. And then okay, I'm gonna finish the template first. Basically, answer equal to system max. Since we're getting the minimum value, that's why we initialize this answer to the max value here. Then in the end, you return the answer. Okay, so that's the normal top-down DP template, and the rest will be we simply just do a loop here for cuts, for cut in cuts. Okay, if the cut is in between, it's in between the start and end, which means that that's a valid cut for the current stick, right? Then we do a answer equals to minimum, right? Since we're going to get the minimum answer plus the DP. So after cut, we'll have two substicks here, start and the cut, okay? And the cut and the end, right? And then plus what? Plus the cost, which will be the end minus the start. And so that's pretty much it is. So it's very straightforward. And how about the base case? And basically, for those 0 and 1 and 1, 2, 3, as you guys can see here, for those like sticks that we cannot cut anymore, for those DPs, we need to return 0. So when we need to return 0, basically, I think for me, I just use basically if for the current start and end we cannot do any cut, then that's the time we need to return 0. So for me, I just use like can cut goes to false. Okay, and anytime when we have a cut here, we just do a can cut equals to true, right? So and here I just do a check here. So basically, if I cannot cut, okay, I simply return 0. Yeah, that's that. Okay, and yeah, basically, if there's nothing we can cut here, we simply return 0, and otherwise, we just return the answer here. We return the answer that's coming from the sub DP problem plus the current cost. And in the end, we just return the DP 0 to n. Yeah, let's try to run this code. Okay, so this one passed. Let's try to submit it. Okay, cool, it passed. Uh, as you guys can see, it's not a very fast solution, but it's a very straightforward top-down DP problem. I think I'm not, maybe there's a better way of looping through the cuts here, you know, or and also to return the to maybe to terminate this recursive call earlier. But mm, yeah, for me, this is the most straightforward way because every time we'll just do a we'll just loop through the cuts here for all we'll loop through all the cuts and yeah, basically. So this is not a very efficient way because every time we have to loop through the cuts and yeah, it's gonna be like what's the time complexity here? So it's going to be the n. So the length of the is n times mm, n square. So we'll have like n sub problems, right? And then for each sub problems, we'll loop through the cuts, and the cuts will go to we'll do two sub problem here. Uh, yeah, so it's gonna be a n sub problem, and we have a for loop here. That's gonna be n times n here. Yeah, this is like assuming this is O1, so I think it's gonna be n square in this case. Yeah, yeah, because the we have we have two maybe I think maybe two n sub problems or no or n sub problems, and for each sub problem we do a for loop here for the cuts, and the cuts is another n here, so it's n square, and the space complexity is O of it's O of n because we will have this memorizations, right? The total element of the memorization, the dictionary will be n. That's the length of the stick here. Okay, cool guys. I think this is like a very very classic top-down problem. I think the one thing if you guys want might need to learn from this is the like same for me actually, same for me. And basically anytime when you guys see like you can basically every time you're given like a different ways of doing things, okay, and it asks you to find the minimum total cost or the maximum, and you should consider basically try all the possible cases, right? And for that, you need to also further consider using the DP problems, and and then for this problem, the you have to basically need to come up with like a, a DP definition here. In this case, is the sub stick, and to define the stick, you need a start and end. And for yeah, and once as long as you have this definition of DP, I think the rest should be pretty straightforward. And basically, you just need to try all the cuts that you can do within this range, and you get a minimum value from it. Yeah, cool. I think that's it for this problem. Thank you so much for watching the video. Stay tuned, guys, and see you guys soon. Bye bye.